All right, so graphing parabolas. Face is frozen yet again. Always in a weird spot. Try again here. Okay, graphing parabolas, but we should add a little more to that because we're going to graphing parabolas like precisely or accurately, not just throwing a U on there and be like, yeah, it's a U, and we kind of get the idea. That's sort of what we did up until now, which was okay for now because we just want to get the basic shape. Now we want to be a little more precise in our graph. So we're going to graph the parent function first, talk about a few things. And then we'll talk about how to do it with transformations. Now, we've already done transformations, so that shouldn't be too hard. Frozen face while itching my nose. So the parent function, obviously you know that's y equals x squared. I'm going to just take it off. We'll try one more time with the picture-in-picture thing. We know it's a u, but let's be a little more precise. And in order to be precise, maybe a table of values. So 0, 0, that's an easy one. Plug in 1. What do we get when we plug in 1? 1. So 1, 1. What would we get? Notice I'm not writing it down yet. What would we get if we plugged in negative 1? Also positive 1. So I'm going to kind of just cheat and make my table of values a little easier and just do plus or minus 1. Since it's squared, it turns it positive. So 1, 1 on either side is one way to say that. 1, 1 on either side. And then if I plug in 2, in fact, I could plug in plus or minus 2 because of the symmetry going on. I get 4 because 2 squared is 4. So from the origin, I need to go over 2 and up 4. Over 2 and up 4. So we knew it was going to be a U, but now we have an accurate, precise U going through like 5 key points. And I want to see those 5 key points when you're graphing today. I want to see those 5 key points. Now, as you'll figure out, it's not like you got to plug in 5 things. You're going to find the vertex pretty easily, and then you'll just go 1, 1 and 2, 4 on either side. So yeah, you end up with 5 points, but it's not like you're doing 5 different things to get those 5 points. Like the vertex gives you one of them, and then it's just 1, 1, 2, 4. Just as a reminder, and because we ask later today, let's do domain and range. How about the domain of that parabola? Negative infinity to positive infinity. If you want to write the fancy R, it's like a script R with an extra, I don't know what you call that thing, stem, line, whatever. You can do that. That just means all real numbers. How about the range for that? Range is the y values from the bottom up. So 0 to infinity. And what about the symbol that goes with the 0? Bracket, because we want to include the 0. One more thing we'll ask for that I haven't used the phrase yet, but I bet you can figure out what it's talking about. The axis of symmetry. So it's like, is that a new thing for today? Like, well, I mean, we haven't used the phrase yet, but axis of symmetry would be the line that makes the parabola symmetric. So, super easy to find. What is the axis of symmetry, though? What's the equation of that line? Good. X equals 0. The main problem is people say, oh, it's 0. Like, well, what's 0? So you've got to tell me x equals, and in this case, x equals 0. Okay, so now we've got a clean, accurate, precise parabola. But if that's all we did, like we'd be done, because there's only one of those, we want to be able to move it around. So with transformations. Now, we've done tons of transformations before, so I'm going to throw you one, we'll do one together, that has like all of the transformations. So -2 parentheses x minus 1 squared plus 3. It's like all the things that could go wrong have gone wrong. And we've done these before, so I don't mind picking on people to come up with or tell me what those transformations are. So Caitlin, you get to go first, which means you can pick whichever one you want to tell me about.
Up 3.
Up 3. All right. Madeline, what else?
You have to flip it.
Flipped. Okay. What about that is telling me the flip? Good. Flip. I'm going to be a little more. I mean, I'm pretty sure this is what you mean, but flip vertically. Emmy, what else is going on?
A vertical stretch by 2.
Okay, vertical stretch of 2. When we say vertical stretch, which coordinates would accomplish a vertical stretch? The x's or the y's? The y's. That will be important in a moment. To make a precise and accurate vertical stretch by 2. We'll fix the y values to stretch them out. Jacob, what's left? The right one. Okay. So yeah, this has all 4 things changed. We've got an up, we've got a right, a stretch, and a flip. So let's see how we can put that on a graph here. Which of those pieces of information should we use first? So there's like 4 things going on. Which? Right one. Yeah, I would accept that, or what's the other one that you could use first? Yeah, those sort of go together. The right one, the up 3. So right one, up 3. I don't know that we really need steps, but step 1 would be find the vertex using the left, right, and up, down transformations. Now from there, I'm not going to do a table of values. It's more like a table of directions. How about that for a table of directions? And you may not even write this every time because you know that the table of directions is 1, 1, 2, 4. Except that not this time. What is different about this? Like usually we go 1, 1, 2, 4 from the vertex, but we're not doing that this time. What are we doing instead, or what makes a change to that? Which of these? Yeah, the -2. In fact, it's good if you just grab the whole thing. And those are vertical things, so we're going to multiply the y values by -2. Again, it's not a table of values because those are not coordinates. They're more like directions from our starting point. Normally we do the 1, 1, 2, 4, but now we're going to flip it over and stretch it out. So I'm going to go over 1, down 2 on either side. Over 1, down 2. And then over 2, down 8. 1, 2, 3, 4, 5, 6, 7, 8.
So what is 1b3?
this one because of the right 2? Or, wait, y3?
Wouldn't be y3 that's
No, the directions are 1, negative 2. So from this point, from the vertex, I'm going to go over 1, down 2. Now that point is 2, 1, but I don't care about the point. I don't want to use points. I want to use directions.
Oh.
That way I can always go from the vertex.
Oh.
So you don't have to plug back into the original because you always will start with 1, 1, and 2, 4. That's what makes transformations easier to deal with. So locate the vertex and then use a table of directions. I don't know what else to call it. Because it's not ordered pairs. It's not a table of values. It's more like from the vertex. Normally we go 1, 1, 2, 4, but now we're going to do whatever change we need to. And then we'll sketch it in. And then I've said this before when we were doing transformation tests, like make sure that your picture matches your words. That seems a little bit silly maybe, but almost always students get this stuff right, and then it doesn't always translate into the picture. So flip vertically, yep, we stretched it out, and we went up 3 and right 1. So I feel good about that picture. Jacob, did you have a question there?
Yes, I was curious if we need to be using that table as work on all of the versions that we do similar to.
So the question was, do we use this table on all of them? 2 ways to answer that. In one way, yes, parabolas are always 1, 1, 2, 4. But be careful, it's not always 1, 1, 2, 4 because we have transformations. So 1, 1, 2, 4 is always the starting table, and then you adjust off of that. The other way to interpret that question is, do you have to write this table out? And that answer would be no. Like if you're in your head, you're thinking 1, 1, 2, 4, and you're going to adjust, that's fine. But be careful, that's a great way to miss a problem is, hey, I don't need to show my work. I can do it all in my head, and then you miss it. So show what you need to show to make sure you get the question right. All right, let's do domain and range and axis of symmetry. Then we'll do some of the problems together. All right. You know what? Let's do it anyway. Carter, sometimes you get the easy one. How about the domain? Yep, all real numbers. For all the parabolas, right? You can move them left, right, up, down, stretch them, flip them. The domain is still all real numbers, so that's never going to change. Benji, the range we've got to be a little more careful about.
Negative infinite and then 3 bracket.
Nice. Negative infinity up to 3 with a bracket. The trick or the mistake that people make on that one is like your brain sees 3 down. Like if you're asking what y values does it cover, like you just naturally want to think, oh, it starts at 3 and goes down. And that's true, but when you write range, you've got to start bottom up. So negative infinity up to 3. Molly, how about the axis of symmetry?
X equals 1.
X equals 1. I didn't even draw it on there. Draw it on if you need to, but that's another one where you don't have to draw it on, but it helps you figure it out. Then by all means, draw it on there. Okay, looking at the worksheet, we're going to do a few together. You know what? Before we do another one of those, and before I forget, turn a couple pages till you get to this page. Basically, we're doing sort of 2 days of notes in one day, and then tomorrow there won't be any notes. It'll just be time to work on the packet. Okay. Let's see. There's a lot of stuff going on here. Polynomial form, or standard form. That's what that one looks like. Vertex form. All of the ones today will be in vertex form because it's easy to get the translations, right? Quadratic translations, so right H, up K. Factored form is what we kind of looked at on Friday when we went from things that were factored and factored them, or not factored and factored them. The main thing about this big page is how do we get from one form to the other? And for our purposes, we're not going to go vertex to factored. We're not going to. You're going to have to go through the long way if you want to do that. Let's see. I want to label each of those arrows, but I think you already know the label for most of the arrows. If I start at the polynomial form and want to land at factored form, what would I have to do to get from this to this? Hint, the word's already on the page somewhere. He would have to factor it. So if it's not factored and you want it in factored form, well, factor it. Got it. What about going the other way? What if it's factored and you want it to look like this? What would you call that? What would you have to do to go this way? FOIL is one word that would describe it. Definitely multiply. Some people would say distribute, but all of those are the same, referring to the same thing. You're just using different words for it. How about from vertex form to polynomial form? If it looked like this, how would you get to that? Yeah, order of operations, or multiply, and then add, or simplify. So all of those are expand it. I don't know what the best way to phrase that. Order of operations is a good way to say it. Like you'd FOIL and distribute, and then add, and kind of blow everything up, and you would land there. Going this way, when it looks like that and you want it to look like this, that's a little bit harder. We'll do that next week. We'll just call that later. All right, there's one more sort of set of information I want to put on this notes page, and that is what you would learn from each form. So back at this form, what could you tell me about the graph if you were looking at, I don't know, y equals negative 2x squared plus 5x minus 7? Like, what would you learn? What could you tell me about the graph if it was in this format? Y-intercept? What would tell you the y-intercept? C would tell you the y-intercept because you'd plug in 0 and you'd get C. So that's one thing we could learn. What else could we learn from that format? There's like one more thing you know that we could learn, and there's one more thing you don't know we could learn yet. What would A tell us about the graph?
How much you compressed or stretched.
Yeah, so A would tell us the stretch or compression. A could also tell us one more thing, and I even put it on this example, whether it's flipped or not. So A would tell us if it's flipped. I guess we should put a question mark there because it might not be. Is it flipped? And then is it stretched?
Is the person here?
Yes.
Okay.
Thank you. And then what we don't know yet, what we'll talk about later, is that the x-coordinate of the vertex is negative b over 2a. That's not really for now, but later. All right, vertex form. What can you learn in vertex form? The vertex. That's why it's called vertex form. The vertex would be HK. It also has the A on there, so all the normal A things about whether it's flipped or stretched. And that's why we like vertex form, because you can go find the vertex, and you know to do 1, 1, 2, 4 after that. So vertex form is easy for graphing because you have the translations. In fact, I think I'd even say it's best for graphing. It's easy to graph it in that form. Do you know what you learn in factored form? In fact, some of you wanted to do this on Friday. We factored it, and you wanted to set it equal to 0, and then solve for x's. And do you remember what those are called when you find x equals R1 and x equals R2? They are the solutions, but there's a word that starts with R that means the same thing as solutions. Resolutions? Those would be the roots. The roots. That format would be best for solving for the same reason that it's easy to find the roots. All right, let's turn back to this front of this worksheet. We're hopping all around today. Okay, here's the good news for today. We're done with notes for today, and we're done with notes for Tuesday. So today I'm going to say the assignment is odds, 1 through 27. And Tuesday, we'll say the evens. I guess we can start with number 2, 2 through 28. Now, let's do a couple together. And then, again, tomorrow, all I'll do is answer questions from the odds and maybe work a couple from the evens, and you'll have lots of time in class to work tomorrow. So let's do number 1 together here. Oh, let's also read the directions because it asks for a lot of stuff. Determine the transformations and graph each function. Okay, well, those go together. Like, you find the transformation so you can graph. And then give the domain, range, vertex, and axis of symmetry. Just make sure you answer all the questions on this worksheet because there's a lot of stuff going on. Okay, let's start with transformations. I should probably just ask somebody how many popsicle sticks I need to draw, but I think I just need 3. Grace, what's one of the transformations on number 1?
Down 2.
Down 2. Jenna, what else?
Right 2.
Right 2. Good. The X stuff is backwards. And Keegan, what else? It's flipped. So there's our transformations. Be careful on this worksheet because the graph paper is sort of specific to each problem. It's not the standard graph. So when you go down 2 and right 2, make sure you're starting from the origin. Down 2, right 2. This one also has a grid that's a half rather than 1, so just be careful. Down 2, right 2. I guess we could label the vertex now, because that's what we just found. We went right 2 and then down 2. 2, negative 2. Normally my directions are 1, 1, 2, 4. What is different this time from 1, 1, 2, 4? Multiply by negative 1, or just flip them over. So again, this is probably not one you need to write out, but hey, if you need to, then go for it. It'll help make sure you accomplish the flip. Over 1, down 1. And remember, it's not an ordered pair, so be careful saying it's a table of values. It's directions from the vertex. Over 2, down 4. Again, careful with the grid spacing there to make sure you go down 4 and over 2. sure I found everything. Transformations, yes. Graph, yes. Oops, domain, range, and axis of symmetry. Domain, range, axis of symmetry. So 3 more lucky volunteers. Voluntold. Giant, how about the domain?
The domain negative infinity false infinity.
Again, always. So that's an easy question, but we want to emphasize over and over and over again, it's all real numbers. Dylan, how about the range? Good. Again, always bottom up. It's tempting for students to say -2 down to negative infinity. I get what you're saying, I get what you're seeing, but you've always got to go smallest to biggest. And then Madison, the axis of symmetry. X equals, what was that? I bet you could draw it correctly. Like there's the,
2.
good, X equals 2. That's another one where you don't have to draw it, but man, when you draw it, it becomes real obvious what the equation is.
For the range, is a negative bracketed or not?
Oh, good catch. Good catch. Definitely bracketed. I forgot to specify. Yeah, because we definitely want to include the -2. Okay, double checking. Transformations, yes. Graph, yes. Domain, range, vertex, axis of symmetry, yes. We did all those things. Let's start number 2, and then I will leave you alone and see if you can finish it. And by start, I mean I'm going to pick on 4 people for the transformations. So, Andrew, give me one of the transformations. Up to. Bella, what else? Left one. This kind of puts Micah on the spot. He's got to just keep adjusting to what he's going to say. Madeline, how about, what else is going on?
A vertical stretch.
Vertical stretch. Can't spell stretch today. Madeline, what does that mean when it comes time to mess with the table? What am I going to do on that table?
Multiply your y's by -2.
Perfect. Multiply the y's by -2. Micah, what else? What's the other?
Flip to vertical.
It's been flipped vertically. Okay, why don't you see if you can finish off that problem? Haven't answered everything yet. Domain, oops, I need vertex as well. Vertex, domain, range, and axis of symmetry. Oh, we almost get through everybody today. Dawson, how about the vertex? -1, 2. I like that. Abigail, the domain?
All real numbers.
All real numbers. So I'll do the fancy R with the extra line through it. Ava, how about the range?
Negative infinity 2
Negative infinity up to 2.
with the bracket.
With the bracket. Yep, good. Keep me from messing up. Ryan, how about the axis of symmetry?
X equals -1.
X equals -1. All right, and just because there's 2 more popsicle sticks to call on everybody. Ella, what's today's assignment? The odds. Karis, what's tomorrow's assignment going to be? The evens. All right, so you got a few minutes left to work on the odds. Again, you can kind of pace yourself. If you know tomorrow's crazy, then maybe do them all tonight. If you know tonight's crazy, then you could save them till tomorrow and be okay. Because no new notes tomorrow. Officially odds today, evens tomorrow.